In this question, we're asked to solve this system of linear equations. And in this video, we're going to do it using matrix row reduction. There are other videos doing this using elimination and substitution. So first of all, for matrix row reduction, we're going to set up our matrix of coefficients. 2, minus 1, 1, 5, 1, 1, minus 1, 2, 3, minus 3, 3, and 8. And then from there, we're going to, in the first step, we are trying to get zeros in these two columns. And in doing that, we're going to leave the first row, all alone. We'll not do anything to it. So how are we going to combine two rows here to get to 0? Well, I'm going to go with 2 row 2's take away a row 1. So that's 2 take away 2. 2 take away negative 1. Negative 2 take away negative 1. And 4 take away 5. And then for this one, I'm going to do something similar. I'm going to combine, this time I'm going to do the row 3 and row 2. So I'm going to do row 3 take away 3 row 2's. That's the easiest way to combine rows here. So 3 take away 3 is 0. That's what I want. Negative 3 take away 3 is negative 6. 3 take away negative 3 is 6. And 8 take away 6 is going to give me 2. Now I'm going to find the zeros in the second column, which are there and there. But whilst doing that, I'm going to keep these zeros here. I don't want to lose those zeros. And I'm going to keep that row the same because it doesn't involve the zeros I'm trying to get. In the first one, I'm going to combine these to get that 0 by doing 3 row 1's add a row 2. That's going to give me negative 3 plus 3 gives me the 0. And I've got 6 plus 0 gives me 6. And 3 plus negative 3 gives me 0. And then 15 plus negative 1 gives me 14. And then for the third row, I need to combine these so that this is, these two, so that this is 0, but this also remains 0. So some combination of rows 2 and 3 here. So I'm going to do row 3 plus 2 row 2's. Minus 6 plus 6. So 0 plus 0 is 0. Good. Minus 6 plus 6 is 0. Great. 6 plus negative 6 is 0, which is our warning sign that we've got 3 zeros there. And then 2 plus negative 2 is 0. Now, this is similar to the one we saw in the last one. The last one we had 0x plus 0y plus 0z equals some number. Now the difference here is we've got 0x plus 0y plus 0z equals 0. Now that is possible. In fact, that is possible for infinitely many possibilities. And that means there are infinitely many solutions to this set of simultaneous equations. Now, what we can see actually from here is a little bit more, because what we can see is that from this first row, we have worked something out. We have worked out that x is always going to be equal to 14 over 6, or 6x is equal to 14, which means x is equal to 7 over 3. So what we know is every solution for this set of simultaneous equations has x being equal to 7/3. But there are infinitely many solutions for y and z that use this particular equation here. So not only do we know that x is equal to 7/3, we also know that from this line here, 3y minus 3z is equal to -1. But because there's only one thing connecting y and z here, we can't solve this equation here. There are infinitely many values for y and z that will satisfy this equation. But for all of those, x is equal to 7/3. So this is an example of a system of three linear equations where there are infinitely many solutions. Again, like the last one, it is very easy to spot in matrix row reduction form because you end up with this telltale line of 0, 0, 0, 0. Remember, no solutions was 0, 0, 0, and then some other number here. But zeros all the way across a row is an indication there are infinitely many solutions. In the other videos, we'll see how we could approach this using elimination or substitution. Personally, I find this the easiest way to identify when this is happening.